besides third-party libraries and third-party integrations, ask any developer what other resources they use for work. It's a pretty safe bet that Stack Overflow will feature. Even security experts. We use this Q&A site that relies on community moderation to promote the best answer and weed out unhelpful programming advice. A couple of years ago, I was still an undergraduate. My former supervisor needed advice. He was programming an Android app and wanted to protect the privacy of its users. But he couldn't figure out how to add a specific security feature that would do this. And he was an expert, so it clearly wasn't his fault. It was the fault of the tool, the framework he was using. So if he couldn't do this, how on earth would layman developers in security even stand a chance to get it right? When he realized he was stuck, he did what most developers would do. He Googled the error, landed on Stack Overflow, and found a working solution to his exact problem within seconds. Looking at the website's view counter, he realized he was not the only one with this particular error. Hundreds of thousands of people have had the very same problem. So first, the good news. This led to vibrant discussions online, a whole bunch of posts, each of them with a long list of suggested answers to pick from. And the website's indicators would ensure you would quickly spot the top answer. So most of the time, those answers come as a code snippet. And that makes it incredibly easy to just copy that code straight into your software and think no more of it. So that's a great user experience, especially for developers with deadlines. So what could possibly go wrong? Most people would be happy getting another coding problem out of the way. However, my supervisor recognized something that presumably hundreds of thousands of ordinary users couldn't. The code example, marked as the best answer and viewed by millions, contained a very severe unknown vulnerability. And that vulnerability was very easy to exploit. So all of a sudden, a research group got really excited. So how could this be exploited? Would it allow them to break into real-world applications? What kind of data could be stolen and what kind of services could be compromised? In a lab experiment, the code snippet found on Stack Overflow ultimately allowed a research group to break into, to capture credentials for American Express, PayPal, Facebook, Twitter, etc. From Android apps with over 200 million users. So for some apps, it was even possible to remotely inject and execute code, for instance, to delete data in apps. In prior talks, my supervisor happily demonstrated how they made a very popular antivirus app delete itself from the user's device. So that's what possibly could have gone wrong. So we were pretty sure that this was not a solitary case. We were curious of how much of the advice on Stack Overflow was actually faulty and could lead to vulnerabilities if reused in the wild. So we systematically collected more than 10,000 code examples from Stack Overflow and over 1 million Android apps from Google Play. We developed technology that would allow us to measure the flow of insecure advice from Q&A sites into an app market just like Google Play. The results were not great. So bad code creating vulnerabilities in apps was everywhere. Over a third of the code snippets given on Stack Overflow were insecure. And those code examples were replicated without any changes in almost 200,000 Google Play apps. 97% of apps that reuse code from Stack Overflow applied insecure code. Among those high-profile apps with an install base of over 5 billion users and apps from very sensitive, security-sensitive categories like finance, business, health, and social media. So after we published our results, we saw a vast amount of follow-up publications. They reproduced our results and showed that this problem existed across programming languages and for a wide range of vulnerabilities. So buffer overflows, SQL injections, everything an attacker would imagine in their wildest dreams. On top of that, insecure advice was even overflowing from one open source community to another. For instance, from GitHub to Stack Overflow and vice versa. On the other side, we also identified a large amount of helpful advice that applied security best practices. Actually, 70% of code examples. So there was even more good advice than bad advice. And for each instance of bad advice, there was also good advice available on Stack Overflow. However, only 6% of Google Play apps reused those code examples. So we wonder, why was bad advice ending up in production code so often, and good advice wasn't? It simply didn't make sense. So we took a closer look at these really nightmarish, insecure code suggestions. Those were a perfect example of Murphy's Law. Everything that could have gone wrong did go wrong. They solved a very popular problem, so there was high demand. They had the highest community-given score, and they were even promoted as a top answer, coming with a green check mark next to it. So usually, each of these mechanisms effectively nudged the best advice to the forefront of the conversation. Those are the incentives that motivate users to contribute and evaluate open source content. So the more the community accepts your suggestions, and the more you rate and check the community, the higher your reputation score. The higher your reputation, the more permissions you get, ultimately leading to more influence and power on the community. So Stack Overflow is pretty much driven by indicators. And our hypothesis was that those were simply pointing in the wrong direction security-wise. That gives us an explanation why all of this has happened. So we did some analysis and started with the most obvious thing to check, the score. It's the sum of people's upvotes and downvotes, and shows what answer the community finds particularly helpful to the problem at hand. Well, the community seemed to really have a thing for insecure posts, unfortunately. Those posts received significantly more love from the community than security best practices. The bad advice was even rewarded with a green check mark a lot of the time, not great. That's what presented to you first. That's where you look at first as a Stack Overflow user. Many users also try to trick the reputation system by duplicating accepted and popular answers across discussion threads to earn additional reputation points for free. That's a dangerous multiplier if those posts are insecure. And indeed, we found out that insecure code had significantly more duplicates. Finally, we had a look at the folks posting this stuff. After my conference talks, people have asked me whether we found any evidence that users did this on purpose. It'd be kind of a cool attack, just to spread your buggy code on Stack Overflow and wait for someone to copy and paste it. Or think of a very powerful attacker or a nation state that might be interested in distributing weak cryptography on a massive scale. However, we couldn't find any evidence, and we think that it's rather unlikely. But what we found was that over a third of the so-called highly trusted users with a particularly high reputation score, posted insecure code. So all the very meaningful indicators on Stack Overflow were indeed pointing in the wrong direction. So what now? The solution is very simple, right? Just don't. Don't use Stack Overflow, that's dangerous. That's the good old paternalistic security advice we just know too well. We developed this amazing authentication method for you, but you're not allowed to use simple passwords. We developed this great framework that allows you to create apps, but you're not allowed to use this incredibly helpful resource to figure out how to do that. Security is hard, so you better learn it the hard way. Read a book, stick to the official documentation, download this additional tool you've probably never heard of to check your code and get it right. So let's see how that works. Let's see what happens if you force developers into using alternatives to Stack Overflow. Well, it's the very same thing we observed with end users and passwords. They are less usable and force them into unsafe workarounds. In other words, they end up code shopping on Stack Overflow once again. A very surprising and disappointing example of this were simplified cryptographic APIs. Those APIs were specifically designed for non-experts with the goal to give them less options to fail. They were tested by experts and compared with standard APIs. and were actually found to perform the worst. They didn't even make life easier for developers, as they were forced to look up the source code of the API to figure out how to use it. And that's the complete opposite of what you want to achieve with an interface. So those tools were oversimplified and only useful for a small range of use cases. That's why people quickly turn to the web again to look for alternatives. Tools need to be useful for a wide range of use cases, and the discussions on Stack Overflow will give you a pretty good impression of what those are. So developers are end users too. They use the security tools we build for them. And it seems to be as much of an impossible problem to alter their behavior and require them to change their incentives as it was for password users. Never underestimate the power of inertia. That's a famous quote of Richard Thaler, who came up with nudge theory and went on to win the Nobel Prize. Altering people's behavior to help them make better decisions is very hard. It's not only security experts that have struggled with this. How can you make people live a healthier life? How can you make people pay their bills on time? How can you make people work more effectively? So those are some of the big questions behavior science try to solve, and you can decide for yourself whether this has been accomplished. But Richard Thaler didn't just throw up his hands at this problem. The quote continues, that power can actually be harnessed. So nudge theory tries to guide people towards better decisions without restricting their options or requiring them to change their incentives significantly. Based on behavioral science, people are steered into a particular direction, but preserve the freedom of choice. So this approach has been shown to be very effective and is already applied all over the world. Translated to our problem, developers can be nudged towards better security decisions without having their options restricted. So they must be allowed to use resources like Stack Overflow, and they don't need to change the way they use it. So the intervention must be easy to avoid and cheap. For instance, putting fruit on eye level in the store counts as a nudge. Banning junk food completely does not. So we won't ban Stack Overflow, but make it easier for developers to stay on a safe path. We do all the hard security work, we read all the books, we develop and apply the security tools to achieve that. This way, we harness observed behavior to help developers make better security decisions. So how did we do that? We started off with the so-called Simplification Nudge, a classic nudge from the literature that promotes building your approach on already existing, well-established, and widely used resources. It's the easiest way to reach the majority of people as quickly as possible. So we implemented this nudge by moving security advice to Stack Overflow. Since everyone is looking at this platform, we believed it could create immediately awareness for the security issues across all languages and platforms. And by using the treasure trove of Stack Overflow discussions on offer, you can learn the security advice for the real-world problems most developers are struggling with. This way, you can make sure that you won't miss the popular use cases where help is desperately needed. Secondly, we want to increase the convenience of the desired behavior. Reusing code examples from Stack Overflow is pretty much as convenient as it gets. By designing a new choice architecture that steers people towards secure code, we can keep this convenience. So we developed a nudge system based on deep learning that knows what suggested code examples are about and whether they're insecure or not. This allows us to perform different nudges on a website itself. For instance, offering safe defaults. The default nudge is one of the most effective nudges from the literature. It simply shows the best option first. Our nudge system re-ranks search results for user queries such that the most helpful and secure advice comes first. And insecure advice remains out of sight and below the fold. Additionally, we warn about insecure advice within the discussion threads, but always offer a way out of the warning situation. So the nudge system automatically looks up and recommends safe alternatives on Stack Overflow that practically do the same thing. By following one of these recommendations, the user gets a very similar but secure code example to reuse. However, since warnings and recommendations are new UI, users might still ignore them. In cases where they might again reuse insecure code, we trigger a reminder nudge that's supposed to draw the user's attention to the warnings and recommendations. So we integrated all of these nudges on Stack Overflow and tested them in a developer study. We mainly needed to test two simple hypotheses. First, nudge developers achieve the very same high level of productivity as they achieved with original Stack Overflow. And second, nudging helps in reusing secure instead of insecure code. So we divided participants into two groups, and both had to solve several programming tasks that require application of cryptographic APIs. While both groups were allowed to use Stack Overflow, only one of the groups received the nudge treatment. The other one was zero control. And since both groups had the same time constraints, we were able to measure productivity. So both groups created apps that functioned well. And statistical testing revealed that there was no significant difference in functional correctness between the groups. So it doesn't matter whether you were nudged or not, functional correctness will stay more or less the same. But what about security? Here we found statistical significance. Nudge developers significantly outperformed the control group in submitting secure solutions. Interestingly, this effect was particularly strong for the problem my supervisor discovered a few years ago. So 66% of the control group delivered vulnerable code. 77% of nudge participants achieved secure solutions. So in summary, our nudging interventions did not harm productivity, but significantly increased code security. And that's what we wanted to achieve. So to me, nudge theory seems like an interesting path to follow in usable security and privacy research. I'm curious and excited to see whether the community will pursue it further. What I particularly like about it is that the way it dramatically shifts responsibilities away from developers that may be laymen in security towards experts in security and beyond. So our team, for example, consisted of security researchers, data scientists, economists, and designers. Of course, I won't claim nudge theory is the silver bullet to solve all usable security problems. But I'd really like to see how much of the approach generalizes to other important problems. Our work gives only an initial study, but it shows that there's potential for fixing important security issues in code on a very large scale. And the urgency to take action is pretty high, as the problem otherwise is much likely to worsen. So I'm at the end of my talk, but it's not the end of our Stack Overflow story. We'd love to see a happy ending where Stack Overflow implements at least some of our ideas. So we hope that this talk was a nudge itself. All right, thank you very much, and now I'm happy to take questions.